Hi guys, welcome back to the course Applied Transport Modeling with Visum. Today it's lecture 7 of this series of course and we're going to talk about the topic on trip generation. My name is Mohit Qureshi. Um, Trip generation is basically the first step of the four-step travel demand modeling that I believe you already have an introduction in one of the prerequisite courses for transport demand modeling. And yeah, this trip generation is the start of our four-step modeling, which is basically talking about how to understand and to create the trip generations for a given network based on their zones. First of all, looking at the schedule of our lectures, today is the seventh lecture, and last week we already had a hands-on live session with Guido again, and he was probably giving you a task about network creation, public transport network creation in Visum, which was probably following a quick guide from the Visum software. And now this trip generation course is kind, you can take it as a sequel of my previous lecture that was travel survey data 2 weeks back. And yeah, in that course, in travel survey data, we were more talking about the types of travel survey and how we can use different travel surveys to do different type of transport modeling. And yeah, today we will basically start our four-step modeling using one of the household travel survey data that I showed you last time. So yeah, today's lecture contents, it will be of there will be of two different major parts. One is basically to estimate the trip production and attraction rates. In we will use R basically to process our household travel survey and try to extract the trip production and attraction rates. And later on, these trip production and attraction rates will be used in Visum to perform the trip generation step, creating a demand model, then you creating a procedure sequence that will do the trip generation, and eventually also we'll talk about how we can do trip balancing. So yeah, again, last lecture, basically, let's take first of all, let's take a small recap of the last lecture, which was about travel survey data. So a few basic major things to the major, I would say the major points to take from that lecture would be like, what is a trip? To understand, I think you should be able to know by now, what do we consider as a trip, and then what are the expansion factors, how they can be calculated. So basically you have a survey, you take a percentage of population, you ask using different questionnaires or surveys, you maybe take 5% of the whole population, a sample of it, and then you need to basically expand this sample for the whole population, and this can be done by extracting expansion factors. Yeah, and the third thing that we talked about was about consistency checks, errors, and their fixing methods. And lastly, we also had a look on a zonal and household travel survey data. So it contained one Excel sheet about the zonal attributes and three Excel sheets about household data, person data, and trips data. So yeah, again, just to revise the previous times discussion. So what is a trip? If you can see and understand the figure here, basically we have four zones, and below these four zones we have the productions and attractions of each zone. So production means all the trips that are produced from the trip, and attraction is all the trips that are absorbed. And if you see zone 1, which is a home zone, all the trips that are either produced or attracted, or like if zone 1 is a origin or a destination, it will be considered as a production for this zone. So here we have four trips that are being produced by home zone 1. Yeah, and if you see the zone 2, which is like a bank, and it's a non-home based zone, there's only one trip that is generated from bank to zone 3 store, and that's why you'll have one production. So this is a non-home based trip. There's no home, either destination or origin. And then when you have a look at 3 and 4, they are only generating one trip each that are going towards home, so we will not consider it as a production for zone 3 and zone 4, but as a production for the home zone. And then same as if I had a look at attraction, so all the zones, although zone 1 has two two trips that are coming into the zone is being attracted, it's considered zero because it's a home zone, and you have no trips that are being attracted to the zone one home, and rather you have one trip that is in the bank that is being attracted in zone 2, and then you had two trips each in zone 3 and 4 regardless. So basically two trips are being actually attracted. So store is attracting one trip from the bank, and also it's generating one trip to home, but both are considered attracted because the other trip that is being generated is going to home. And similarly for work is the same thing, that it has two trips that are coming and going. So it's home to work and work to home, and these two trips are considered home, two productions for home and two attractions for work. So basic idea that is different here is just that all the home based trips are considered production for the home zone and attractions for the other zones. And now let's think about let's revise a bit about the expansion vectors. So basically, this is a simple table that defines, okay, we had a household in steady area. So it's a expansion for a household survey, and we had like, for example, for the first one, we had around 5,764 uh, household in our study area, and we surveyed 35. Now it's a very simple thing to just simply expand by dividing 35 with the total number of households, getting expansion factor of 164. Now the major point to take out from here is that we are dividing population into different segments, because when you'll do a survey data, you will have more detailed groups by income, by household size, by car ownership, by all other attributes. And it's very important to like in statistically, when you do surveys, it's very important that when you're dividing something by a group, you should have sufficient statistically significant surveys. You should have sufficient surveys for each type of the group to get a statistically significant outputs from that survey. So for example, here we are saying that, okay, we are dividing the groups by income and by car, and low income with car and low income without car. And so if you see that they have very different survey sizes. So one is 35 and the other is 120. But also if you see the households, the size also is like four times, from 5,000 to 20,000. So the point is that it cannot be possible that you have, like, for low income with car you only have five surveys and you have still 120 surveys for without car. So if you have only five surveys, you cannot do this classification, because you will not have enough surveys for one type of data. So if you get any kinds of outputs based on low income with car versus maybe with car and without car. So if you just divided with car and without car, you would might have better amount of surveys in all the groups, but it's possible that you can have lesser if you divide it more and more. So it's very important to consider that different groups should have enough surveys. So this is one understanding. But for expansion vectors, it's rather simple, that, okay, you have to find an expansion vector, you have a total some population size, and you have a sample, and you can simply divide the sample with the whole population to get the expansion factor. Yeah. Okay. So these are the two things that we had from last time. And also, I would also like to show you another basic thing that so I also already gave you an Excel file that we tried to just manipulate a bit with R, very basic, try to load it and try to just see how to check, to have some consistency checks. Now here, this was the Excel file. Probably you can see it now. Yeah. Okay. So we have basically four different types of data. So the first one is zonal attributes, which has 24 zones and information about each zone. Then we had a household data. Then we had the person data. So household is each household size and other attributes. Then within the household, so like this household, the first one, has persons inside it. So it will have, in the person, it will have like different person records for each household. Like for the first household, there are like three person records, which is like two females and one male. And similarly, when you go to trips, it will be further subdivided, that each person, this would be about the person ID that we had previously, and each person basically further has number of trips. So if you see, this person has three trips, and this is from home to escort, home to shopping, home to escort. and it's probably a female, and it's done by car. So yeah, this is the basic data that we will start with, and now what we'll try to do today is try to use this trips data and the zonal attributes to create the production and attraction rates in R. So first, let's get back to the lecture and try to understand how we will do these things. So I'll probably gonna do this like more dynamically. I'll show you the slides. So after one or two slides, I'm gonna go straight away to the R file, doing also the processing that I'm showing in the slides. So yeah, for trip generation, we will start with some assumptions and considerations that we should keep in mind that we are already considering in our model. So first one is no external zones. So external zones are something that is basically, so normally a network, if you remember, is divided into spatial zones. So these spatial zones will be like polygons that are covering a network. And then there's also So then there is also, you can consider there will be a substantial either through or so there can be some traffic that is either going through to the city or coming in to this our steady area from outside the steady area, or going out from our steady area to outside our steady area. So we are right now considering no external zone, which means that all the trips that we will model are either produced or attracted within our steady area. So no through traffic, no traffic coming into the steady area, no traffic going out of the steady area. Then the considered modes we have is car passenger, car driver, bus, bicycle, and on foot. It's rather simple to understand. And then um, now this is a home-based trip, so this is already I've showed you the assumption, but again to say just to have them stated here as well is that okay, two home trips are reflected of from home trips and single trip record. Oh, okay, no, sorry. So this assumption is rather important for you to understand. Now, single trip record for both home and from and to home trips. Now, this means all the trips that are from somewhere to home are not being like not are not used directly, but they are merged in to the trip that is like from home to somewhere. So a simple example would be you have a person that goes from home to work and then comes back from work to home. Now this will be considered a single trip. Now this is done for simplification because we have a large, so almost everybody has to go from home to back home. So we can substantially reduce our computation efforts by reducing almost all the trips to half, you can say. There will be a lot of home-based work trips, and we can simply consider them as one. And so yeah, we will see the benefits later on as well for this thing. And now, so the next thing that also there is like for car ownership. So if a car's ownership means yes, it means that the car is being used regularly. So if somebody is using a car regularly, he's considered as car owner. It can be car passenger, car driver. Then all others are non-car. So if somebody is using it regularly, he's a car owner. If he's not using it regularly, he's using it once a week or something, we'll consider him a non-car owner. So the next thing, so these are the few assumptions that we consider within the start of our four-step modeling. The next thing is okay. Now, as I was describing you, so a basic idea to divide our demand groups based on the attributes. We create a demand model which has different subdivisions based on purpose of the trip, demographics, genders, car ownership. It can be a lot more other things. So the basic important idea is that we can get more and more details about each type of demand groups by further subdividing them based on their attributes. Now, this is basically based on the modular or the modeling purpose why you're trying to create this FOSTA model. Now you can be very abstract, create only home-based trips or just trips, or you can have home-based work, home-based other non-home. Now this trip purpose that we have right in front of us is a very basic simple one, home-based work, because so the idea is there will be like a substantial amount of trip that is home-based work, around 60-70% of all the trips are mostly home-based work trips. And then okay, 30 to 40% trips, they can be like okay, they can be like 15% out of these 30-40 can be school, then okay 10 to 15% can be shopping, and then okay 10 to 15% that can be leisure, right? But these are like more mixed together between the zones, so there can be some zones which has a lot more school trips than interaction of shopping because there is no shopping area, and similarly others, right? So, and non-home based trips are very hard to be further subdivided. Somebody can go from work to shopping, or from like school to leisure and then whatever, some things like this. So basically this is like a very basic type of trip purpose distribution that we use. So home based work, home based rather non-home based. Gender is rather simple, male and female, and then car ownership, yes and no car ownership. Now this right now we, so this is a basic one that we are considering currently in our demand in our four step modeling. But as I'm telling you, it's upon the modeler you can further subdivide your trip purposes. You want to have a car ownership or not, but car ownership is rather important when you go to the mode choice step. Gender, male, female, it's upon the modeler because it can be really helpful or it cannot be helpful at all, depending on how you want to use your model. So yeah, so basically currently what we are going, so I showed you this is the current division that we're going to do in our for our demand. So we have the trips data that I showed you in the Excel file, and the next thing is that what we're going to do, we're going to create this demand model, and for this demand model we are going to create our trip generation step. So we're going to start with trip production and extracting the trip production and attractions for these types of demand groups. So we're going to go straight to our Excel file data, load it into R as tables that I showed you last time as well, and we'll start working on it. Yeah. So to start with, so basically we need two major things. So um, we want to extract trip productions and attractions. So productions, as I'm saying it, as you consider it, are basically all the trips that are produced by a zone. And these trips, the productions are mainly based on the population. So if a zone has 1,000 inhabitants, it would create 1,000 into a factor trips. So each person will do either 1.5 to 2.3% of the 2.3 trips. So an average you can say, right? So a zone with inhabitants of 1,000 can create around 2,000 to 2,300 trips. Similarly, so different zones based on what their population is will have the production rates based on the population. And for attractions, so attractions are basically based on the trip purpose, right? So it should be work, it should be leisure, it should be shopping, it should be school. So as we can see the zone attributes, so if you see the zone attributes, we have for each zone all the other attributes that are basically the trip purpose. So it can, so we have for each zone what, how many workplaces do we have? The jobs. Then we have recreational area. So we'll have a factor for recreational area. So areas can be in kilometers square or some other unit, right? And then shopping area is also like it's in meter square probably, and then school places also like the number of places or number of student slots that are available, and then kindergarten places. So all of these are basically defining how many people can be attracted for this purpose in a given zone. So for attractions we will basically have all of these five types of different repurposes will have different attraction factors that will basically multiply with that zone's work or any other type of attraction purpose. And then for production we'll have basically production is done by the population itself, right? So we will have a factor for the inhabitants. So for example, for zone 1, we might have a production factor of 1.5, 1.3, 1.2. So this basically we will be extracting it from the actual information of the survey. So from the trips. So from the trips in zone 1, how many people are in journal making a trip? How many trips people are making within one day? We will get a factor and we'll basically use that as the production rate. So now how should we extract this? So we'll go back to our slide. So first of all, we will be using these two packages I already described. So read Excel is basically to read the Excel file, and dplyr is basically to manipulate the tables. And so we'll start with reading all the data sheets from the Excel file about zone attributes, household, person, and trips. And then the next thing is we'll create a simple new table for the zone attributes. And but to create a new table, we'll simply select um, the zone attributes in the zone from the zone attributes, these four columns. So let's see this in the R file. So okay, yeah. So basically, first of all, so I'll probably I've also uploaded this R file already, so you don't need to write it by yourself. And to do this, so we'll go first gonna see if you have the packages that we need. Do you have them installed or not? And the next thing, next three lines, we are basically loading these three libraries, and then these four lines are simply to load the file. So I already had some data, so I'm just gonna do this thing again. So I'll just remove my workspace variables and I'm gonna start this again. So I've loaded all the libraries and now I have loaded all the four tables. So you can see these four tables as you saw in the Excel file. Yes, and the next thing, so I know what I need to do is basically to find the production and direction rates, right? So to do that, let's only start with creating. So as I told, the production and direction rates are based on the zonal attributes, right? So we're just gonna create a table for all the zones using only the few variables. So before, zone attributes had a number of different columns, and we just extracted a few. So now the example that I'm going to create here, so that example, and I'm going to demonstrate in front of you, we are trying to have a simplified one. Yeah, and for that we are not using all the other attraction rates but only workplaces and schools with inhabitants. But you can simply either use the same zonal attributes, or you can even write here the other columns that you need. For example, the shopping area. So if you just write shopping area here, you will also have the shopping area included as a column. Yeah. So this is one thing. And the next, we are also creating. So so as you remember, so basically we will have the demand groups as home, with the trip purpose as home-based work, home-based other, and non-home-based. Yeah. So for now, we are going to work with home-based works. So first of all, we'll start with creating the production and attractions for home-based work trips. And for home-based work, the origin is home and the production, then the attraction or the destination zone is work, right? So we will start with filtering all the work trips. To do this, we'll use this line, which is okay, filtering all the trips. So trips is the trips table that we have, where we have all the survey trips. We're going to filter this trip table with two conditions. First is purpose at origin with home and purpose at destination with work. So this means all the trips from home to work. Yeah. Again, because as we stated before, the assumption here is that all the trips that state work to home will already be inside this. So this home to work trip means that the person is going from home to work and coming back from work to home. So this is two trips basically in a simple version, but a single trip is that is going towards home is already been absorbed in home to work trip. So yeah, this is also the visualization that we will do in R. So let's go back and do this. So first we have this zone the zone table that we have created, and the next line, this is the next line that we will basically filter work trips. And if you see the work trips versus the normal trips, so this is the normal trips table, which has like purpose of origin and purpose of destination, that is home, escort, home, shopping. So there are many of them. So more education, shopping. So education is probably school, yeah. And if you see the new work trips, you will see only the trips that is at home and work. So this was our basic purpose, yeah. So we have created a table which has all the work trips. I also had a line that I wanted to show you that, okay, similarly, if you want to like it's a very simple tool of filtering that if you want to filter similarly for home-based others, all the trips, so you can create another table that is other trips with a filter that says, okay, trip filter the trips table with the purpose of origin as home and the purpose of destination not equal to work. Now, if you will do this, it will basically extract from the trips all the records that don't have purpose of origin as work. So you will not able to find any work trips inside. Yeah. So this table will be basically used when we will work on home-based other demand group. So with the purpose of home-based other production. Right? So right now we are just still, as I told you, we are just focusing on demand group of home-based work without any other thing. So just to simplify everything for you, like a basic step, just to give you the lecture and everything. So we will have only working on the demand group that is like home-based work with no other further classifications like male, female, car ownership, nothing, just home-based work. Yeah, and then so next is we're gonna look how we will gonna find the production attraction rates. Yeah, so we have already basically extracted the information that we require from our survey data to do okay, we have how many. So as I told you, productions are based on inhabitants, attractions are based on the trip places, the attraction places available in the zones. Yeah, so we have already extracted our required zone attributes as a new table of zones, and we have already extracted similarly all the trips that are actually been done for home-based work. Yeah, now next is that we're going to start working on trip production and attraction. So the first line is self-explanatory. So it says that okay, the trip production and attractions basically represent all the trips that are either produced or attracted by each zone. And then we basically have two estimation methods that we use majorly to do this type of estimation. First is cross classification and the second one is linear regression. So probably you'll have a better idea than me about linear regression because you have probably finished your statistical class a lot fresher than me. So you already have taken probably in first semester, I guess, the class on applied statistics, and there you already knew what is about linear regression. Linear regression is basically trying to find the best fit for a number of different attributes. Yeah, so we're gonna have a look at this. So but basic idea, as I told you, for productions are always based on population, and because population is a single attribute only, cross classification will be an easier method to use. And for attraction, because you have multiple attraction purposes, so 3 or 4, we mostly use the multiple linear regression technique, where you have a number of different you can say variables, and you'll try to find a best fit or factors that satisfy all of them for the number of given trips that have been done by the survey. Yeah, so let's get into the first one. So cross classification, it's very simple. So for each demand group, the production or attraction rate can be simply given as that what is the total number of survey trips divided by the total number of persons. And if you see the simple example which says that okay, the total number of home-based work trips that we have surveyed versus divided by the total number of persons that are present there. And if you see in R, we already use the filter function that we are describing here, that okay, for filter function, the filter function can be used to create new tables for specific demand groups. So we have created a table for home-based work trips, and then the rates can be evaluated similarly for different all different demand groups. Yeah, and also um yeah, so trip expansion factor is required to take into account. So this is something that is also rather important. So um actually what is happening, so let's go back to R so I can give you more visualizations and we can discuss better. Now for cross classification it's rather simple, that okay, we want to find a mean number of reps for a given purpose for all the persons. So let's suppose if zone 1 has like 1000 zone persons, and from zone 1 there is like 2000 work trips that happen. It means we simply divide those 2000 divided by the 1000 persons, and you will get that okay, 2 work trips per person is the production rate of this zone. Yeah, this it's a very simple way. Yeah? And now one important thing is that okay, we have work trips. This is a survey data, this is not for the whole population but for a sample. And we, as we saw, we already have expansion factors for all different types of trips. Yeah, so this is what we are mentioning in the lecture, that okay, also take into account the expansion factors, that okay, you just don't need to take the division of work trips divided by the persons that are surveyed, but the expansion factor of work of the trips divided by the expansion factor of the persons. Yeah, and let's first try and run this simple code line to get the division and get the production rate. So if you see, we already have a production rate of 14.8 for all the work trips and all the persons in our study area. Yeah, and okay, so let's see a simple distribution for this. So let's say that okay, let's see what is the length of the work trip. So we can simply write, I hope, I'm not very good with R, but okay, I hope we can simply write this and we'll get the length. Yeah, so we get the length of 12. So we basically have, okay, 12 should be the columns, I guess. So length is wrong, so length, okay, but okay, let's see it here. I'm sorry. So we have 240 work trips, and then how many persons do we have? So if you want to see the persons, the persons that we have is 1887. So if you want to find a production factor by yourself, you can simply do 240 divided by 1887, and you will get a production rate. So this is a production rate for our survey. So we have 240 work trips and we have 1887 total persons that were in the survey, and we get a production rate of 0.127. But the important factor that we want to also consider are the expansion factors. And if you go back and see the trips table, you will see in the last column you have expansion factors, and similarly for the person you also have the expansion factors. And I have already described you, for example, a person expansion factor is rather simple to be extracted. Now this is already given to you, but I have given you an information that okay, if you want to extract an expansion factor, the basic idea is that you should know how is the distribution in the population and how do you have the distribution in the survey, and basically you just simply divide the values, the amount of different types of person groups in your survey by the amount that you have in the population. And that is the idea that how these expansion factors has been extracted. But we are not showing you all the information. Okay, so here basically the expansion factor for this type is that okay, female and age between 18 to 65. These are the only two informations that we have, right? And the expansion factor for this type of group should always be rather similar for a zone. That is also important. So you have, so the three distinct informations that you have is zone, gender, and age group. So for this zone, this one and this one, this will be the expansion factor. And similarly, let's see a similar one. So if you see this zone 11 male and above 65, you have this expansion factor, and similarly is the same here as well. And for female it's 20 1.87. Yeah, this, and again, so I haven't I'm sorry, I haven't given you the information before, but this data that we're working on is not an actual data, but it's a synthetic data that we created with a synthetic network. So this not nothing of this is of real information, but the idea, so basically we wanted to create a synthetic experiment to demonstrate you the four-step model. And yeah, you can see the basic this idea you can see about the basic idea about expansion vectors. So expansion vectors are based on discrete groups. Yeah, each group will have different information, but okay, per group the information or zone type, the gender, and the age group is same. Similarly, if you want to see trips has their own expansion factor, and now this expansion factor is only for mode car, zone destination, zone origin, home zone. So all of these trips they will be same only for these types of it. So if you see the first trip expansion vector is for, so the for the first person, probably the trip expansion vector is the same, and for the next person, so let me see, so this is changed, and so yeah, so the trip expansion is actually the same for each person. Let me just, okay, yeah, so for each person the trip expansion vector is the same. Yeah, and now what we are trying to do, because although you have the same expansion vectors for person and trips, but the amount of trips that will be done by different persons are different. So here for the first person you have um you can say three trips, versus the second person which you only do one trip. And now when you do the sum of this trip expansion vectors divided by the sum of this person expansion factor, you will have a different value, because you understand, right? So the number of trips by each person is different, and you will take a sum of the trip expansion vector, you will get a different value when you take the ratio. Yeah, let's see, this is what we are trying to do here. So we are using the expansion factors, and when we basically sum the expansion factors for work trips divided by the expansion factors for person trips for persons, we get the production rate, that is 14.8%. Yeah, so this is the basic different idea. So this is the method of cross classification that I think you better understand now, is that simply you divide the number of survey trips divided by the number of person. Now the server trips can be of specific purpose, demand group, whatever you want to choose. The next thing, so this is the table also that demonstrates this, that okay, work based, so yeah, so for the let's suppose these are three different purposes. So work with home based work, home based other, non home based, yes car, no car. So you have these six different demand groups, and each demand group will have basically a population, number of persons, and so no, sorry, so each record of these six demand groups will have trips, right? So home based work with yes car are 3322. Yeah, and you also have the total persons with yes car and with no car. So what you will do to find for each one of them, you'll simply divide 3322 by 21560, and you'll get a percentage or production rate for home-based work yes car as 15.4. This is the simple idea. And similarly, you can see for all the values you have the production rates. So these all are different trips for home-based work, home-based other, non-home-based, yes car and no car, and then you have total persons with yes car and no car. And now you can simply find. So this is basically trying to give you more detailed understanding that okay, if you instead of having just home-based work or home-based, like just having the demand model representation as home-based work, home-based other, or non-home-based, that is by trip purpose. If you have it by the demographics, by male, female, yes car, no car, you will have different amount of total persons with demographics, right? So here we are also dividing the demand model by the car ownership, and you have two different person groups, that is yes car and no car, and then you have three different trip purpose groups, that is home based work, home based other, non home based. Yeah, And yeah, so this is basically the idea how you can extract production rates with cross classification. And let's try to spend some more time and try to quickly see, like, okay, if let's just try and find. So home based work we already did. Let's try to create non home based, and to do this we have, okay, home based. So we have other trips. We can say, okay, let's call it home to other trips, and then home to work trips, and then, okay, last one is known home trips. Okay. And to have known home trips, we will say that, okay, all the trips that don't have the origin at home, that's it. Because so we don't have any record that is attracted by home, so we don't need to really filter anything from the destination, but everything from the home. Yeah. And so let's do these things again. So we'll have home to work, we have home to other, we have non-home. So we have now three different tables: home to work, home to other, and non-home trips. And now we'll find three different production rates. So the first one we did already was for work. So let's rewrite the name again, and person is fine. And so we say, so we'll say, okay, home work rate, trips rate. Okay, let's call it trips. It's not, it doesn't look that bad. Non-home trips, sorry. Yeah. And now when you'll divide for each different group, you will have three different rates which are very similar. Let me see why. Okay, sorry. Yeah, because I haven't changed the tables here. Yeah, so now we'll have three production rates for each type of the trip purpose. So the first trip purpose is home-based work, which will have a production rate that we already calculated, 14.8%. The next one is home-based other. So starting the trip starting from home, but going not work but other places. That is 73.8%. So a lot of trips that is home-based others than work, which is okay. No. And then non-home based trips, that is, okay, all the trips um which don't have their origin as home. So you'll see that, okay, now this means that there's 36.3, there's 36.6 trips, oh sorry, you can say like 0.366 trips per person. That's why I'm calling it percentage, I shouldn't, but 0.366 per person trips that are non-home based. So people that are going from work to shopping, or I don't know, school to some other activities. Yeah. So I hope you understand now better the production rate. I will also spend more time to give you the understanding of person groups, because it's also very important. Although I mean we can also have like homeworks and stuff, but I let me just quickly try and create the code and I'll show you this. Yeah. So yeah, so I'm not gonna show you the complete way of adding a person based group classification. So here, but I'm just trying to give you some direction for this. So before, what we work is like home based trips, like the sorry, not home based trip, but the trip purpose based classification, that is home based work, home based others, and non home based. Now if you want to add further classification that is based on person or demographics, like car, no car, or male or female, here I'm gonna do like male. So this is rather simple. So now you will create tables each including the information that it is either male or female. So with the filter, now I'm calling this, okay, home based work trips male. That is, you will do the filter for all the trips that has home work, and also that is, okay, person is equal to male. That is simple. Yeah? And similarly the other one female. Yeah. Now I'm not gonna tell you how you should do it, but I'll give you basically the kind of a basic task to do this, and to basically try and merge this. So if you see the trip information here, you don't have the information to have what is the person that is doing the trip. So if you see all the trips, you have origin, destination, whatever, but you don't have is it either male or female. So for you, my question would be that do you know how you can extract or you can attach the information for either it's male or female? And first you need to attach it to the table, and the next thing you will try and filter then male and female production rates. Yeah, so then we will have, instead of three groups, we will have six groups, that is home based work male, home based other male, non home based male, and similarly three groups with female. Yeah, and now you'll have like six demand groups. But you cannot extract the information directly without manipulating a bit the strip table. So attaching the information of male and female, and I'm going to give you the task to try to understand and find how you can do this. Yeah. So this is simple. Now I'm going to go further from production list to the attraction list, but also we will have a homework after 2 weeks about trip production, so trip generation and distribution, where probably I'm going to have a live session and we can cover this thing again. So probably first I'm going to ask you guys to do the homework, and then I'll do the homeworks in front of you. Okay. So okay, let's continue with our production. So the next slides. So yeah, so we have seen how we are doing the cross classification, and now we will look the basic concept of linear regression to find the trip attraction rates. Yeah. And so to find the trip attraction rates, as I told you, because we have more than a number one types of attraction attributes for a given zone, that is workplaces, schools, kindergarten, recreational area, shopping area, so five or six, we will need to use multiple linear regression. And a simple multiple regression is used to estimate the number of trips that is produced or attracted by different demographic attributes. Yeah. And there are two different types of regression. So the two major types is either zonal based regression, that is using the zonal attributes that I just told you, or you can also do this by household based regression, that will use the household attributes. So household size, income, number of workers, car availability. Yeah. So there's more detailed. This is a more detailed, of course, field itself of doing the regression by different types of data classification or data attributes. Right now we're gonna just see a simple version of this to find the attraction rates based on the first type, that is zonal based regression. So the idea is that, okay, given the equation that we are seeing here, is that, okay, y is the total number of trips that is attracted for a demand group. It's also important for a demand group. Yeah. And this y is based on a1 a2 till an are the production and traction rates, and x1 x2 till xn are the attributes. So for example, if you want to understand for home-based work, what are the attraction rates? Now the idea would be your y is the total number of trips that are attracted home-based work. So, and x1 is the number of workplaces available. So if a zone has 100 workplaces available and it attracts a given number of trips, you will find basically a factor a1 for this. Yeah. So it's actually very similar to cross classification, given that, okay, if you have only one type, right? So that's why, so why we use cross classification right now in production is that, okay, we simply, what we do is like we only have inhabitants, that is only one type of attribute, and we can simply divide our number of trips by the number of persons, that is number of inhabitants, and we get the rate. Similarly, if here you only have one type of attribute, that is for attraction, let's suppose you want to find for work, it's simple that, okay, you can even divide, like y is equal to a1 x1, right? So a1 is work rate, is the rate for works, and x1 is the workplaces, and you can simply divide the total number of trips for y, that is y, divided by the total number of places available, is equal to, you get the factor, that is a1, right? So it's similar, but multiple linear regression is used when you have more than one attribute. Now you have to satisfy more than one types of places. You have workplaces, you have schools, you have others, right? So this is like a1 x1, a2 x2, a3 x3, This is the idea. So let's go further to do the linear regression step in R. And yeah, so we will basically start again. So we'll just try and find the what you can say, sorry. So we'll try and find the trip attraction rates for home-based work. So in this lecture, we're only covering home-based work, although I'm showing you on the hands-on other types as well, but here we are just doing home-based work. So let me just go to the R file back again. Or actually, let's just see the slides here, right? So you understood the concept of linear regression. You know it better, of course, as I told you. You already just finished the statistics course, and we basically cover this there as well. But the simple idea I've given you that okay, you have all the attributes, and you will try and extract the rates for that attributes that satisfies the given number of trips that are from the survey. Yeah. Now, to do this in R, first what we will do, we'll again extract the trips table, which is only home to work, and then we will summarize the work trips by the destination zone. So this summary will basically have, if we have 24 zones, for all the 24 zones, how many work trips are attracted for this zone as destination. Understood? Yeah. So again, you have 24 zones. So a summary table will be all the 24 zones with the number in front of it, the number of work trips that had this zone as the destination. Yeah. So the number of work trips attracted. Simple. And then we will basically add this information to home-based work trips to the zone trip table, so it's a zone table. So we left join in the zones table the work trip summary, and basically now this is what we needed. Now this table is what we needed basically to use in the linear regression for finding the attraction rates. Yeah. Also, it's important that we also mentioned here a note that okay, if you see this so this percentage greater than and then percentage, these signs, this sign is used for a piping technique in R. So this way you can write multiple different types of manipulation commands and it will run it only once altogether. So this is a very nice piping technique that is in R to simplify the code, to reduce the code a lot more. And we are basically, what we are doing is like, first we group by all the work trips to all the work trips by the zone destination, and then we take a summary that is saying that okay, total trips is equal to sum trip expansion factor. So we are not just summing the records but the expansion factors. I already gave you the concept behind it. Yeah. So yeah, we are doing two operations by using this piping function on this trip work trip table. So this is again the work trip table, and this should be the summary as I told you. So we'll find from this work table for each zone how many total trips were actually attracted as home-based work, and then we attach these total trips to the zone table that we had. So zone table has workplace, inhabitants, and the total trips. And once we have that, we will basically use this linear regression in R to find the trip attractions. So let's first get till here in our R model, in our call our code. So again, what we need is, okay, we need work trips only. So I have rearranged a lot of things in my R. So let's just put everything else in brackets for now. And I'm gonna call this again as production rate, so the way I had it before. Yeah. And okay, I had zones, I had work trips, and I found the production rate. Yeah. And now let me just remove everything because it will make you easier to see what are we doing. So let's run this thing again. So till here we had the, so okay, sorry. Yeah, so before till here we found already the production rate, and now we had this work trips table already that we have here, right? And now what we'll do, we'll create the summary, and to do the summary, as I showed you, like we'll create a new table that is work trip summary, having the work trips grouped by zone destination and then summarized, taking the sum of those each group that we do the group by, taking the sum of the total of the expansion factors within that each group. So first we group by, create groups by zone destination. There will be 24 groups, and then for each group we will summarize, or we'll take a sum of the trip expansion factor. So when we will run this, we can simply get a new table that is work trip summary, that you can see also on the slides. And next we will have joining the work trip summary with the zones updated. So we use the zone table. This was the zone table before, and we attach in the zone table this work trip summary. So calling it zones updated. So zones updated is here. That is okay. Zone, workplaces, school places, inhabitants, and the total trips. Also, this NA is something that okay for so I'm not sure. Let's see if we have it actually. So we have like a number of zones which actually don't attract any workplace work trips. So this is also important because the workplaces, if you see in zone 6 and 7, are just 10, and it's possible that the people that are living inside the zone are filling up those workplaces, and there is like nobody in our survey that's actually going to that work or to in that zone. So that's why we don't have any trips, and we have actually NA. So there it doesn't give you a sum 0, but it says that there's no record. So it says that no values simply as NA, and we will basically use this line to shift the NA instead as 0. So now if you see back again the zones updated, you have all the values as 0. Okay, now let's go back to the slides again. And yeah, so you see this is what we have done so far. We have attached the total trips for each zone based attracted as workplaces or home-based work. So we have 2090 workplaces, and we are attracting 669 trips from other zones. You'll think that okay, the workplace is a lot more than the number of total trips attracted. It's also rather possible that a lot of the workplaces within this zone is filled by the inhabitants that are inside the zone by walking and biking or whatever. Yeah. So let's go next, and now we'll perform a linear regression now. And to do this, we use an LM function that is from the dplyr package, and we need to basically specify a regression formula and the data table to this LM function. Yeah, so basically the formula, what it does, it specifies the dependent and the independent variables. And here if you see, the dependent variable is total trips, and the independent, I guess I'm not wrong, but yeah, the dependent variable is total trips and the independent variables are work trips. So if the work trips increase, the dependent variable, that is total trip, will increase by a factor that we are trying to find here. Yeah, so this is the formula that is like okay, work trips, workplaces plus 0. 0 is also like the C coefficient. I'll give you this idea. Let me give you a demonstration here. So for example, this is a basic example of linear regression model, and if you see in the top one, the best fit line is crossing the y-axis at an intercept. Now this intercept is the basic value of C, and when we define our equation saying that the total trips is equal to workplaces plus 0, this means that we want to have a linear regression line crossing at 0 on the y-axis with y-intercept as 0. So this is the basic difference between the integration with an intercept and integration with 0 as the value of C. So yeah, next is that okay, now we basically try and find so we have defined the linear regression model LM, total trips, workplaces equals plus 0, and then we will find the attraction rate. To get the value of the attraction rate, we will say that okay, the coefficient of this linear regression model is equal to the attraction rate. And yeah, this is also I'm defining here in the note that 0 is added in the formula to remove the intercept as I showed you graphically. And then the example calculates attraction rates with workplaces only to include other zone attributes. They should be added in the formula. So let's go in R. So this is the visualization in R, first of all, in the slides to see the regression. So we ran the same regression model as we described, and this is the coefficient. So this is the regression model that you will see. So when you will run this line, basically, you will have the linear regression models something like this, and which has like all the coefficients of each, which will have like here we only have work, home-based work, so we have only one coefficient, that is 0.256. But if you have more coefficient, more number of attributes, you will have more coefficients. But yeah, this is how you can visualize the coefficient, and you can set the attraction rate is equal to coefficient linear regression model, that you will have the attraction rate as 0.256. Yeah, so that's it. Let's go back. Yeah, and let's go back. We come back to R, and we'll see how we can actually find this. So it's just two lines here. We have the linear regression model as we said. So we are using the package LM total trips plus is equal to workplaces plus 0. Data is the zone data, zones updated. Yeah, so we run this, and we got the linear regression model is a list of 12, and we can see that okay, this is the different residuals and all different other values that we have from a regression model, and this is basically the coefficient 0.25618. Yeah, and the next thing is that if you want to set it the attraction rate as a variable with the coefficient, we can find attraction rate is equal to 0, and we can also print it if we want. That is like for workplaces 0.25618. Yeah, now I'm gonna give also also demonstrate you the other way that okay, it's very similar. Right now what we used is actually the same as the cross classification technique, and let me just write the code for that and I'll show you again. So now you have understood how we can find the production and attraction rates for a given network using its trip survey data and zone attributes for each zone. Yeah, and so we have been, so just to recap is that we have been looking into two different types of production attraction evaluation methods. That's the cross classification and linear regression. And next, that once we have the production attraction rates, we will go and start modeling the first step model in Visum. So I'm going to show you next the slides how you can do the same, how you can run a trip generation step in Visum given for a given model. So first we'll try and copy all the zones. So we already have the network and the spatial zones on it. So the zone shapefile is already loaded and everything. The next thing that we'll add is basically all the zone attributes for these 24 zones, and we will basically also input. We'll create a procedure sequence for the trip generation, and also within that procedure sequence we will input all the production and attraction rates that we have just evaluated. And to start with Visum, first, so to cover the trip generation in Visum part, I will in this lecture. So I will first go through the few slides, defining a few steps, how to create the demand model in Visum, and then how to create the how to fill in all the different types of subgroups, and then basically going to create the procedure sequence and everything. So I'll just go. I'll try to cover first of all a single part in slides, and then I'll go to Visum and show you more how hands-on on video, the how you can basically do all the trip generation step by step in Visum. Yeah, so to start with, basically first of all that you have to do is to set up a demand model. Now if you understand and if you remember, I'm going to go back to the slide, that okay, what is a demand model? A demand model is basically trying to create different demand groups, and as we discussed, demand groups can be trip based or person based. Trip based is based on the activities that you want to subgroup. Basically home based work is a work activity. Home based other is like all other different activities from home. Non-home based activity is all the activities not starting from home or ending home. Yeah, Secondly, person groups can be for person attributes or person demographics. Male, female, car ownership, yes, no, or something else. Income groups, it can be age groups, income groups. All of these are basically can be person groups with person attributes. Yeah. So So first of all, we're going to go and create a demand model. And to do that, we'll simply do this step, demand models. And then in the demand models, we'll create a new demand model. We're going to set this type as standard 4-step model. And then we're going to specify modes, which we're going to consider all modes. Right now, we just have bike, car, and public transport. And next is the next tab here. So from basis, we were basically on the basis which define where we defined a new demand model, and then in the person group we will define different persons. Right now, because we are just working, as I told you before as well, we are just working with just one demand group, that is home based work for all persons. So here we in person groups we only have just one group, that is all persons. Here you will basically define if you want male, female, car, no car, income, low income, high income, medium income, young, middle aged, old age, so all the person based attributes groups. Then the next tab would be the activity based. There is like, okay, what different types of activity based groups you want to create: home based work, home based other, non home based shopping, home based school, home based something recreational, whatever. Yeah. So this will be basically different types of, so you will have each code, you will have a code for this home based work, and then you have name home based work, then you have code home based others and the name. Yeah. So it's rather simple. And then once you create this, so basically you have the person group and activity pairs. So based on these two divisions, you will create basically the you will create demand strata. So when you click on this create demand strata, when you go to you will see that in demand strata you will have all the different attributes. Right now, because we have just one each group in activity and person, you have a home based work all basically. So they basically what will happen is like you're basically combining the two chords all and home based work, and it's like called home based work all. Yeah. And next is like simply you're gonna press OK, and this is how you set up a demand model. And let's go back to Visum quickly and just do a quick hands-on this thing. So first, basically, you go click on demand. So this is the network that I've uploaded as the model.ver file. So you can simply double click. So you should have Visum. I guess you already have it because you're doing the quick guide from the two quick guide tutorials from Guido. So basically, you already have a Visum though, but I'm giving you a new demand model file which we're gonna work for the 4-step model. And this is the file. You simply need to double click on the model.ver, and the Visum model file will open. And from here, basically, you just need to follow up the steps that I'm defining to you. Yeah. So this file already has most of the things predefined. So we have if you see these polygons, these are all those 24 zones. Then you have these roads that are private transport, and also the blue ones are the private transport, and probably the orange ones are the public transport, and yeah, some other attributes. So we also have the connectors. So if you see this is zone 5 and it has these connectors, and then this is zone 10, it has these connectors. But I mean, you already have covered well in the previous lectures how you want to work on the network. Yeah. So let's go creating the demand model. To start with, you will basically simply click demand models. Here basis, you create a new demand model. You say standard 4-step model. Name, you can say whatever you want to. And then all modes you have to select, and you say that okay, all modes, and then that's it. Yeah. And then next, person groups. In here, right now, you can say all, and then name all persons. Yeah. But you can also, as I told you, you can also that okay, you can also say male and female if you want, right? That is the idea. But I'm gonna first show you the basic one that I have in the slides, and then I'm gonna create the other one if you like, if you want to have a detailed one. So activity pairs, you need to create a new one. You say home based work. Activity pair name is home based work. Yeah, that's it. And no, because you have created this and this already, you just need to click on create demand strata, and will automatically create a new demand strata that is with the code home based work all. name you need to probably define, but okay, that's it. Yeah. So you have the person groups, you have the activity. So it defines okay which person group is the activity pair. Yeah. And that's it. Yeah. So this is something new that was not there previously. So for each mode, I think you don't need to select. Okay, exactly. One demand segment should be selected. I would select also, but probably is that you can also define the mode that this type of activity should be using. So you can select all. I think it should be fine. Yeah. So that's it. So if you see press OK. So basically, when you go demand model, you have in the demand data one group that is home based work all. Now let's try to create another. Let's just manipulate this one and say okay create. Let me just first save the file so that I don't need to create all of them again. So I have this, right? So just a moment. So I'm gonna quickly create. I deleted the previous and I'm gonna quickly create another one that is like okay, let's try male female, right? So we'll say male and we can say similarly female. So two person based groups, and then activity pairs you can say home based work. So let's create three, and then the first one is home based work, second one is home based others, and the third one is non-home based. So you understand the idea here again, right? So these three are the activity based group pairs, and then this is male female is the demographic based person groups. And then once you have this, you can simply create the so currently you don't have anything in the demand data, and then once you have filled these two, you can simply click on create demand data, and you should have. Okay, so no, you have only created two, so probably you will need to go back to activity pairs, and you have to select all of them, and then when you create demand data, is already existing. So let me I mean you can delete it, whatever, it's your choice. But okay, the idea is like even if you do this, you need to create a master data, and this creates all those. So these home based other male female all of them. Yeah. And then also if you want, you can get them from this tab or this tab as well. And if you select only one with this tab and create, and it will only create, it should only create the male, right? So you have to choose all of those which you need to create the master data for. So if we choose both of this and then you'll do this, the create a master data, you will have all of them again. So this is the other version that you can do if you want to go detailed with all the activity or the trip purpose and some person group. It can be also male female. Instead of male female you can have car no car, also you can have with male female car no car, right? So male car, male no car, female no car. Yeah, so things like that. We'll then have 12 demand groups. So you also have seen in Visum how we can create this demand model setup. And then the next thing that we need to do is to add the zonal attributes that we have in the Excel file in the Visum model, right? So we already have the zone, as I told you, we already have the zone shift file in this model. And the next thing is that we'll try to add different attributes for all the zones, and these are objects just like other things, just like a road, just like a public transport line, or just like a zone itself. So we need to add more user defined attributes for defining these different attribute information for the zones. So to do that, we need to go to the network and say user defined attributes, and then when you click next, you will basically see all the objects defined by the user. So here you have links, stops, lines, as I told you, everything, right? And then so what you'll do is like you will basically press this create button to create a network object, and then in this network object you will select zones and press OK. And within, so for so it will be a network object type of zone. So once you click this, you will select zones, and then you'll press OK, and inside zones you have an attribute ID work code name. That's it. And is it what data type it is? We are only working with numbers, so integer, and then okay. And then basically what you say is like you have a new object with the object type name as zones, and then the attribute ID work short name, like so this is a new attribute for zone table or for zones. Yeah. And similarly for work, we'll also, similar to adding work, we will add all the others. So we'll have kinder, we have population, we have recreational, we have school, we have shopping, we have work. So we'll have six. These are the six information that we have from the Excel file as well. So basically we will simply add all of them one by one as user defined attributes. And now next, when you will go, sorry, so next when we'll go to see the list of the zones, so when you click right click on zones and list, you will see the list about zones, its id, its number, and all the other attributes that we just added, and there's nothing here, so basically there will be zeros. And then we will basically manually copy all the information for each zone from the Excel file to this user file. So we can simply click on the Excel file table or select all of them and copy and then paste it here. So yeah, so let's try to do this quickly. Going back to the user file, we will start by defining new network attributes. So we will go, so let me just quickly see if my file is back. Okay, yeah, the file is back. So network user define attributes. So here we will click add button, create button. Here we will select zones as our network object type, and then in zones we'll say okay, work and integer, yeah. And similarly others, that is okay, school, okay. So just as I described in the slides, I have created for all the different attributes for all the different types of zonal data. I've created all the user attributes, that is population, work, kindergarten places, recreational places, shops, and schools. Yeah. And the next thing is okay, as we discussed, so we have to copy basically within the zone list all of the zonal attribute data from the Excel file. And to do that, we will go to zones, right click, list, and here we will see basically all the different the names or whatever we have said. So all the different type of user defined attributes we have just added. So my names are not actually very good. Let me rearrange them quickly. Yeah. So these are the six attributes that we have just added, and now the next thing that we'll need to do is basically try and add the Excel file data. So I'll have this here. I have the Excel file data, and here basically I have. Okay, let me just see. Okay, that's fine, I think. So I have workplaces. I have, so my arrangement is not actually very nice, but okay, let me just rearrange and then we'll. So what I'll do is just basically simply copy this here and then paste it on the workplaces. And similarly, for next thing is schools. So I'm just gonna copy schools and paste it here. So this is just trying to replace everything. Um, all the attributes on attribute data into the Visum file. So recreational, and the last one should be shopping. So yes, so now we have all the zonal attributes data in our model. So these are all the 24 zones, and these are the different work, school, kindergarten, all the different places attributes. um, Let me save the file, and then I'm gonna go back to the slide. And yeah, here, so we are till here we are covered already, so I've shown you the hands-on. And the next thing that we'll do is basically to create the procedure sequence of trip generation. To do this, we will go to calculate procedure sequence. So this procedure sequence is the area where you will try and define all the different processing steps. So trip generation, distribution, mode choice, trip assignment. Within this, we will also create some different other, so to try to find distant matrices and stuff. So all of these different procedures are defined here in a sequence. When you want to change something in the model, you will define a sequence here, doing trip generation, distribution, all of these, like in a sequence. You can define a sequence of procedures here, and whenever you go back, you change something in the model, you can simply execute the whole sequence. So this is the idea behind this procedure sequence. Yeah. And to start with, we will say a new procedure, that is like create, and then we'll say like trip generation, the new procedure sequence of trip generation. Okay, when the trip generation inside the trip generation procedure, We need to find the reference object, that is, okay, which demand group you want to do for the busy sequence. You can, if you have only one, you can select one. If you have more, you can select all of them together, or you can even do trip generation one by one. But I would say that, okay, if you have three demand groups, you can simply select all three together. Yeah. And next you can do, you have to, so basically define the parameters in trip generation, which are under this variant. So if you double click this, you will go parameters, and here you will basically define all the production attraction functions, matrix balancing that we will just discuss now. So we already have the projection and attraction rates from R. So we will first try and input those. So we will click on this. So this is the sequence of doing this. So we will start with clicking on this three dots. You will add the formula as 0.149 that we got the production rate into, we'll multiply, and then we'll add a new attribute from the zonal data. So we'll basically click this, and then we'll come here, we'll click this, and then once we have clicked this, you will see that we will have this as so inside the zones you can select different attributes, and population was the POP was the basic short name that we set for the population attribute, and we write this search and we select population and press OK, and then we press OK, and basically we will have a formula that is like for the production function, it's 0.4149, that is the production rate of all the zones, multiply by their population. So this will give us all the productions for each zone. Similarly, the attraction rates will be the same, that 0.256 is the attraction rate that we got from the linear regression, and multiply them with the workplaces, because it's home-based work attraction rate. So multiply it with the workplaces that are for available in each zone. And once you have that, you have the production attraction function. Next important thing is about metric balancing. So what is matrix balancing? Matrix balancing, I think you already remember them. You do, you would have done a tutorial and exercise in TPMO, transport modeling. I think something like that. That is from the course you did in the first semester, I guess. And there you are doing alterations to balance your productions and attractions together. Yeah. Or no, I think it is the same thing. But yeah. So matrix balancing is always done fixing either the production or attraction, or taking a mean of both, minimum of both. But normally you fix either production and you rearrange attraction, or you fix attractions and you rearrange production. Here we are doing the matrix balancing based on the production total, and now we'll see why. So what is trip balancing? So for home-based trips, so in trip balancing or matrix balancing, if you have the trips that are home based, this means that all the home based trips, as we know, all of them are basically produce, the home end is the trip production end, irrespective of the direction of travel. That means that, okay, either it can be like work from home, it's still home as the production and work as the attraction. Yeah. So this is for these all the home based trips, the production totals are used to do the matrix balancing. And the reason is that we are very reliable, that the population or the household attributes, like the population and the household attributes are more reliable, and we are more certain that, okay, this is the population and this is the production rate based on each population. Attraction rates are first of all more than 1, 4, 5, and we use a linear regression model to extract the attraction rates. And while for the production or for the population is rather simple, so we are always trying to do matrix balancing, fixing the production rates, that we say that we are more certain that the production rates are more better and the amount of producing the trips for each zone is much better than what we understood, that what is the amount of attraction for each zones. Well, for this is for the home based trips. Next would be for the non-home based trips, and in the non-home based trips, even these are the people living out in homes, but the original destination is simply outside. And we have, or we should use the attraction total as the trip balancing. And the reason for that would be that although these are not home-based trips, we are still finding their production based on the population. So if you remember, the production function is a factor or production rate multiplied by the population. And these non-home based trips are starting from work to shopping over time, right? They don't go home at all. So we should say that the attraction totals are more certain here than the production. So that's why when we do trip balancing, we consider attraction totals as fixed. This is the simple concept behind which type of trip balancing you should choose. Yeah, and here because we have home-based work, it's a home-based trip, we simply use the production total, which we feel are more reliable and certain to be correct than attraction rates or attraction totals. Yeah, so we set the metric balancing and production total, and then we will simply execute. So we will mark this as ticked. We can click this, or you can maybe right click and say execute marked procedures. But if you simply have this active and if you simply press this, it will be executed. And once you execute the procedure sequence, when you go back to the zones list, you will see that you have the production and traction total available. I mean, this will not be there already. You have to add these attributes into this list table. I'm going to show you how. So basically you need to click here, select attributes, and inside here you have to search production and attraction and press this call this direction here to add this inside the table production and attraction. We'll go and visualize this in Visum as well. And but yeah, this is the overall idea that we have for doing the trip generation. Yeah, so I have in this lecture, so let's first go to Visum and then I'll give you more. So this is where we have left our Visum model, and we have where we added all the zone attributes as new user defined groups. And the next thing, as we discussed, was calculate. We'll go to the procedure sequence, and in here we will start with creating a new procedure sequence, defining inside the demand model trip generation. Yeah, and this is the new procedure sequence that is like for trip generation. And the next thing is, okay, what is the reference object? Is basically the demand model you want to use. So you can use different demand models that you have defined, and it says those demand models, how many demands groups you want to find the trip generation for. Right now we have only one, but if you have three, you can choose all three as well. And once you choose one, next thing is like the variant file. Inside the variant file, when you choose only one demand model, you will have only this one column. But if you choose if you choose more demand groups, not demand, you will have more demand groups written here. So it's simple. So this is the demand stratum. So more columns, more rows means all the more demand groups that you choose. Right now we only have one and we chose only one, so we have only this. And then we'll simply write, as I told you, like okay, 0.148 into, and we'll select this, and then we'll go okay simple, and then we'll click here and we'll write pop, and we have the population. It's like this. Okay, we select okay, and we simply have the formula written here, and then we simply say okay. And this is how you can define a production function. Similarly, to define an attraction function, we had this, I guess, as the attraction rate, and then we go here, we press this and we press work, and this is workplaces, and then you simply say okay, okay, and you get the work attraction order. And now the last thing that we discussed is about the matrix balancing, that we do production order for home based trips, and for non-home based we do attraction. And this is it, and then we can simply say okay. And next, to execute this, we can simply press, we have to set this active. We can execute it by this, we can by like right clicking and execute mark, or we can also do this, and this executes our trip generation procedure. And to see the productions and attractions, we have to go zones list. Here we have all the attributes that we had before, and it's not visualized, so we have to add the columns of production and attraction. We simply click on this, select attributes, and here we can find productions, and we can put it inside our column. And similarly we can say attractions, and we can put this in our zones list, and we'll say okay. You get the new productions and attractions. Let's see if if they are the same as we had here. So 395321. Okay, similar, not exactly the same, because I think the attraction rate that I wrote is not exactly the same, but yeah, they are similar. Yeah, so this is the method. So I'm going to save my file here, and this is the basic method to do the trip generation in step in Visum. So basically we did what we did was like we found um, the production and attraction rates based on the our trip survey and zonal attributes using R. And once we got that, we went to Visum, we defined our demand model, and once we defined our demand model, we created a procedure sequence for trip generation. And in that procedure sequence, we inputted that production and attraction rates that we received from the R code. And once we had that, we simply executed and got the productions and attractions for each zone in Visum. Yeah. So next lecture, we are going to talk about the next step of of the four-step model, that is strip distribution. And so we have basically four steps in a four-step model by the name: trip generation, distribution, mode choice, and traffic assignment. So trip generation we have covered, and the result of trip generation is basically the production and directions for each zone, the number of trips each zone produce and number of trips each zone attracts. Next is trip distribution, and the results of a trip distribution is a simple OD matrix, a trips OD matrix that has all the trips from each zone to all other zones. It's a simple OD matrix. If we have 24 zones, we'll have a matrix of 24 by 24, with each cell having the trips between the trips from going one zone to the other. Yeah. Mode choice is like, okay, we create multiple OD matrices, one OD matrix for car, one for bus or public transport, one for bike. Yeah. Traffic assignment is when we assign these OD matrices onto the network and get the network state, the volumes, the public transport usage volumes, the road volume counts and stuff. So these are the basic four-step models. I think you understand them as well. So yeah, see you in the next class with the lecture on trip distribution. Yeah. Have a nice day. See you then. Bye.